Forest operations are constrained by ecological considerations, such as hawks' nests. We have hawks' nests showing as red dots. One of these intersects the area that we have selected for a forest operation based on the proximity to the road, 250 feet, and the high sawlog volume, over 100 cubic meters per hectare. We are going to approach this by two methods. Before we do either, I'm going to export this selection into a new data layer so we can work on it on its own, and that will make it easier to follow this demonstration and go back and forth. So right-click, Data, Export Data. I'm going to call that demo.shp. We are exporting the selected features. So we have 171 of these cells selected. And yes, I want to add that. So there's our demo area. I can turn this off. So now we're looking at our hillshade and our elevation layers. And I'm going to make this the only selectable layer. So selection, make this the only selectable layer. So then if I select this, I only get this polygon selected and I don't select the roads or the hawk's nest. So with that done, I'm going to go through the quickest and easiest way to remove areas that might be within a specified distance. We're going to say 150 feet of this hawk's nest. And that is to use the Select by Location tool. Only instead of selecting, we're going to remove from selection. So Selection, Select by Location, and we are targeting the layer Demo with the source layer hawk nests that are within a distance. And that distance we said was 150 feet. But now instead of selecting features from, we are removing from the selection. So you see we have all of these layers selected currently. When I hit apply, it will remove from the selection those cells that have any portion of their boundary within 150 feet. So apply, boom, that has removed all of these cells. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Lucky 13 cells have been removed from our selection and our operation. So we can hit OK there. But if we zoom in on this nest, we can use the measuring tool, make sure we're going to measure in feet. If we click on our hawk nest, we can see that only the very edge of this cell is within that 150-foot distance. Most of it is not. So we don't actually need to remove this area from our operation. We could go ahead and calculate saw log volume for the entire block as is, but we can in fact operate these areas. So that is going to be our second method. That's method number 1 done. You can now proceed from the same method as the previous video, if that's what you choose to do. But the better way is to first create a buffer around the hawk's nest and then erase those portions that overlap. Then you can recalculate the volume in a slightly different process than the way we did before. So I'm going to clear all these selections. I'm going to use Geoprocessing, Buffer. The input feature is the hawk nests. The distance is in feet, 150 feet. You can accept all other defaults and say OK. Now we have hawk nest buffer, and that is showing if we make it hollow. This is the buffer around the hawk's nest that we've chosen. We can see we have an issue with this road. We would have to either have our landing somewhere else or not use that little spur road. This is our main road that we're getting in on. This is an older, smaller road, so we couldn't drive in there if we were looking to not disturb an active nest. So we have this road here, and we want to clip out this portion but not this portion. So we're actually going to use the erase tool to remove those areas that overlap with this Hawkes buffer. So we'll search for tools, erase. The input feature is going to be our demo area. These are the forest inventory cells. The erase feature will be the hawk nest buffer. I'll go as demo erase to my default geodatabase. Okay. So now demo erase will take the place of demo, and you see it's chopped out all those areas that overlap with the Hawkes buffer. So that's what we want to have done. So now we have a layer that is only the operable stands with the constraint of the Hawkes nest. But before we were able to simply take the average of all the per hectare saw log volumes for all of these, and then we were able to multiply that by the acreage of each one of the blocks. We can't do that anymore because now these blocks are all different sizes. And if you were looking closely, we actually have that situation up here as well, where when I clipped this out, I cut off some of these, and these are all smaller than the regular cells, so that's not going to produce a perfectly valid measurement for the affected areas. Now this is one of our key important blocks, so we're going to treat this properly. We are going to calculate first the saw log volume for each one of these cells, and then we are going to sum those rather than averaging. So to do that, we'll go into the attribute table. We have all these different variables to work with. We are concerned with the saw log volume, and that is saw log volume per hectare. So we need to first calculate the number of hectares in each cell, and that's going to be a fraction of a hectare for each one. And then we're going to multiply that by the saw log volume per hectare. So this shape area, that's in square meters, so that's not what we need. We're going to create a new field, hectares, make that type double so it can have plenty of decimal places. Right click on hectares, calculate geometry, set the units to hectares. We'll use the coordinate system of the data source. It's the same as the data frame in this case. Okay, so now most of these are 0.039977, which in the metric system is just moving the decimal place over 1, 2, 3, 4 places. But you see that some of these are very much smaller, and that's going to be a case like this, where we've cut one of those cells in half, or if we use the information tool, we'll see that the hectares is 0.013617 for that, because that cell has been cut. So now we can go back into the attribute table, clear our selection so we're acting on all the different features. We'll create one more field, add field, type double, and name vol total. Okay, and now we can use the field calculator, right click, field calculator, such that volume total equals saw log times hectares. So we have saw log in cubic meters per hectare, multiplying that by the total number of hectares gives the cubic meters. Okay. So now in this cell we have 4 cubic meters, in this one we have 0.6. We can display any one of these using the information tool. We have 3.226522 cubic meters in here. That's much more precision than this actually deserves, but that's what we've been given. So we have about 3 cubic meters in that cell. In that one, in that tiny little sliver, if I can click on that accurately, we have 0.4 cubic meters. Just a tiny little bit, but now that we have that calculated, we can get that volume accurately. So now we have our two-step process of first dissolving our demo arrays, and no multi-part features. And this is just the same as the previous video. So we have our dissolve, and then we are going to apply the negative buffer distance so that it does not share a boundary with the adjacent cells. Because I've already exported that, that's actually not necessary. We don't have any adjacent cells. So this is a step that you could skip if you were doing this with a layer that you had already exported. We'll do it again here just to demonstrate. So we are constraining demo erase dissolve. We're going to apply a negative buffer distance of 1 foot, just enough to back it off. Okay. So now we have these, which represent the blocks, and we are going to assign the sum total of the volumes that we just calculated, rather than the average. Before, we took the average of the per hectare saw log volumes and multiplied that by the area of this. Now we are just going to take the sum of the saw log volumes that we calculated just now. So, joins and relates, join, spatial join, and we are going to use our demo erase layer, and rather than average we want sum. Okay. So now we have our join output, and if we scroll all the way to the right we have the sum volume total, and that is going to give the total volume for each one of these constrained blocks, accurately accounting for those portions of the blocks that were removed due to the hawk's nest. So let's have a look at our highest saw log volume, and that's this one here. If we use the information tool on this one, we can see that it is now a total volume of 47.8 cubic meters. Because it's been separated from this, these are now two different blocks, and that little sliver over there has 5 cubic meters. So that is the accurate and precise way to account for the volume lost to this hawk's nest. It is accurate in a way to use the first method we demonstrated in this video, but it will not account for those portions of the block that do fall outside of this buffer, so it will underestimate the volume of the block that you're going to cut. So I would suggest using this method if you're interested in absolute precision, as of course you should be. Otherwise, it is good to know how to use the Select by Location tool to remove items from a selection.